All right, what's up, guys? Gonna give you some help here on the 7H notes. We're gonna tie together some of the stuff that we did from 7G over here to 7H. Talking about quadratic equations. We may get in some graphs, quadratics and stuff later in the week, but just talking about these in terms of circles here. Okay, so whenever we have an equation that has an x squared and an x, all right, it's impossible to get x by itself. You can't do it. Okay, so all we can do is factor it. Okay, we could factor it because long story short, with the quadratic equation right there, all right, you may have a graph, and the graph is a U shape. Okay, and so a lot of times there's going to be two possible x values at a certain y value. Okay, so there's two possible answers. That's a way it's impossible to get x by itself because x could be two different things. Okay, and so there's two correct answers for that, and so that's why with quadratics we can't solve it in the typical fashion of just get x by itself and we're off to the races. Okay, so what we got to do is we got to take our quadratic equation and we got to make it equal to 0. Okay, all right, we have to make it equal to 0. Okay, that's how we set the thing in motion to factor it. Okay, so the format that we need to get our quadratic equation, we're going to have an x squared minus, I'm going to call this that coefficient b x, and then it should be plus, not minus. I'm sorry. So x squared plus bx plus c equals 0. Okay, so long story short, we're going to have to move all the terms to one side. That way the other side is just equal to 0. Okay. Now, what we're going to do is when we factor this thing, and this should be reviewed from algebra 1 and maybe even before, what we're going to end up with when we factor it, we're going to get two sets of parentheses. I'm going to call this x plus d and x plus f. Okay. And those two parentheses are going to multiply to 0. Okay. Because again, all we're going to do is we're going to take this x squared plus bx plus c. We're going to factor it into two separate parentheses right here. Now, what's going to happen is we have this parenthesis times this parenthesis equals 0. So now we know that if we're multiplying two things to equal 0, either this parenthesis x plus d has to equal 0, or the other parenthesis x plus f has to equal to 0. Because again, if I'm multiplying two things, whatever they are, just sort of a sidebar over here on the other side. If I'm multiplying two things, a times b, and it equals 0, okay, the only way for that to happen is a equals 0 or b equals 0. That's the only way that we can multiply two things equal to 0. Well, the same thing applies over here. Okay, over here we're gonna end up with two parentheses that multiply to 0. So one of these parentheses, x plus d, or the other, x plus f, has to equal 0. Okay, so really the work here is trying to find out what our d and our f are. Okay, now to find the d and the f, the d times the f, okay, the d times f is going to equal our c value up here, and our d plus our f is going to equal our b value up there. So it's going to involve some guessing and checking, and I'm going to show you a nice simple process on how to do that. Okay, I'm going to sort of show you over here on the left-hand side of the screen. But we're going to do all four of these problems here on these notes just to make sure you're good. And again, once you're cool with it, you could always stop the video and go forward to the circle part. Okay. So I'm going to erase all this. All right. So we're looking at our first problem here. X squared plus 15x minus 34 equals 0. Well, we should know there already that it's already set equal to 0. So we're already kind of in shape, sort of ready to go here. Okay. So what I need is I'm looking for two numbers. whoops. So I'm looking for two numbers that multiply to negative 34 and add to 15, okay? So we're going to look for two numbers that multiply to equal negative 34, and the same two numbers have to add to 15, okay? Now, the easiest way to do this is let's make a chart of all the terms that multiply to negative 34, because it's easier to find out number pairs that multiply to a number than that will add to a number, because adding, there's an infinite number of terms that could come together to add to 15. All right, well, there's only a certain number of terms that could add or that can multiply, to negative 34. Okay, and so I know some people in the past have done like a little. I think it was maybe called the butterfly method or the X method or something like that. And so, feel free to do that if that's what you're comfortable with. This is a way that I've taught for years that I sort of think best. So I'm going to find numbers that multiply to negative 34. All right, I'm just going to make a little chart. All right. Well, I know if they multiply to negative 34, I'm going to have a positive and a negative. So I could have a negative 1 and positive 34. I could have positive 1 and negative 34. Next, the only other terms I believe are negative 2 and positive 17. And positive 2 and negative 17. I believe those are the only numbers that multiply to the only number pairs, that multiply to negative 34. Okay. So now what's going to happen is I want to add up these two terms. So negative 1 plus 34 is positive 33. Well, that ain't going to work because I need them to add to 15. So those are out. Okay. 1 plus negative 34, that gives me negative 33. Well, again, that's out. I want to add to 15. Negative 2 plus 17 is equal to 15, okay? And then 2 plus negative 17 is equal to negative 15, which is out, okay? So we're left with negative 2 and 17, okay? So we're left with negative 2 and 17. Those are the numbers that we're going to put in for our D and our F, okay? So we're going to have a equation of x minus 2 and then x plus 17, and it equals 0. Okay, x minus 2 times x plus 17 equals 0. If you remember the FOIL method, okay, basically we're taking this and we're unfoiling it. We're putting it back into two separate parentheses here. That's really what the factoring a quadratic sort of ends up being. Okay, so I have x minus 2 times x plus 17 equals 0. Okay, now to solve it out, again, there's two possible things. Either this parenthesis, x minus 2, could equal 0, or this parenthesis, x plus 17 equals 0. Okay, and so if x minus 2 equals 0, we know that x would have to be equal to 2. And if x plus 17 equals 0, x would have to be negative 17. Okay, so these are my two answers. X equals 2, x equals negative 17. All right, if we were to plug this into our calculator, all right, plug 2 in for x, okay, this equation would end up being equal to 0. If we plug negative 17 in for x, the equation would also equal 0. Okay, so there's, again, with a quadratic, there's two possible answer choices for x, which is why we just can't get x by itself. Okay, so let's do these other three here just to make sure we get a little practice here. Okay, this second one over here, again, it's not equal to 0. So we got to make it equal to 0. So we're going to move that 34 over there. And so if we take the 34 and add it, because it's negative 34, we have to add it. We have x squared minus 14x plus 40 equals 0. Okay, again, all we're doing is moving the 34 over there, combine it with the 6. Okay, so again, I'm going to make a little chart. I need two numbers that multiply to 40. Okay, multiply to 40. All right, so I have 1 and 40. I could also do, -1 and -40, because two negatives multiply to a positive. 220, -2, -20. We could have 4 and 10, -4, -10, 5 and 8, -5 and -8. And I believe these are all the pairs of numbers that multiply to 40, I believe. Yeah. Okay. So again, add the two terms. 1 plus 40, 41, out. Okay, because we're trying to add a -14. All right. -41, out. 2 plus 20, 22, out. -2 plus -20 is -22, out. 4 plus 10 is 14. Well, we're getting close, okay? But we need a -14. Luckily, we have our -4, -10. Add up to -14. So -4 and -10 are our numbers here, okay? So as we come here, we're going to end up with x minus 4 times x minus 10. Those are all going to multiply to 0, okay? So making these parentheses is just rearranging this equation right here. We don't change anything on the right-hand side, okay? So if x minus 4 equals 0, or x minus 10 equals 0, okay? So move those around, x equals 4, or x equals 10, okay? So that's that. Hopefully this is a nice way to sort of organize it for you guys. If it's, if there's another way that you learn that's a little bit more comfortable, like the little butterfly X method. I know a lot of students have used it in the past. That's fine. Whatever, as long as you're doing it correctly, you're good. I just think making a little table is sort of a nice way to organize it. Okay. All right. So over here we have, a lot happening here. So we have x squared minus 45 plus 3x equals 7x minus 32, or 7x plus 32, excuse me. So we need to move the 7x over. So we got a minus 7x. And we also have to minus 32. All right. And we got to make sure we rearrange it to where we have x squared and x and then our number. Okay. All right. So we have x squared. That doesn't change. All right, we have the 3x minus the 7x, so that's going to be a minus 4x. And we have negative 45 minus 32, which I believe is negative 77. All right, so we have x squared minus 4x minus 77 equals 0. So again, I'm looking for two numbers that multiply to negative 77. Okay, so we know 1 and 7 and negative 77, or negative 1 and 77. And then I think we have 7 and negative 11, and then we have negative 7 and positive 11. I believe those are the only pairs that multiply to 77. All right. So again, as we look at these, 1 plus negative 77 is negative 76. That's out, okay, because we want to add a negative 4. Negative 1 plus 77 is 76. That's out. 7 plus negative 11, negative 4, and we have our winners. Okay? 7 and negative 11 because they add a negative 4. So we're going to get x plus 7 is one parenthesis. X minus 11 is the other. Okay? And each parenthesis sets equal to 0. So x plus 7 equals 0 and x minus 11 equals 0. Okay? On this very last one here, it looks like it would be easier to move the 4x squared over, and I'm just going to show you all a quick little trick. So, the real right way to do it would be minus a 3x squared and add 17x and minus 84. It's a lot of stuff, but there's kind of a quicker way. I'm going to show you guys how to do one like this in case you know, you get confused because a lot of people might just say, okay, let's just minus 4x squared, move it over. It's sort of the quickest path to 0, and that's fine. So we get 0 equals negative x squared minus 17x plus 84. So we just move the 4x squared over. Okay. Now, thing is, we have negative x squared. We don't want that. We want positive x squared. And so we have to sort of change the signs around. But all we have to do that, if we ever end up with like the negative x squared right there, all we have to do is change the signs of everything in here. All right. So we could just change the negative x squared to positive x squared. Okay. And we could change the negative 17x to positive 17x. And then the positive 84 to negative 84, and then we're set to go. Okay. So if you need to change one sign, that's fine. Just change the signs of everything in the equation. And, you know, 0 and negative 0 are the same thing. So here, you know, we'll do our table with trying to find numbers that multiply to negative 84. Okay. And so, you know, trying to find numbers that multiply to negative 84 that add to 17. So, you know, we have 1 and negative 84. Those add to 83, so that's out. We have 2 and negative 42. 2 and negative 42 is negative 40. That's out. We have 3 and negative 28, I believe. That's out. 4 and negative 21 and negative 4, positive 21. Trying to shortcut this thing here a little bit. So we know those are out, those are out, those are out. 4 plus negative 21 is negative 17. Close. If we flip it, okay, negative 4 plus 21 is positive 17. And so that's what we got, because again, 17 is our B number there, okay? So we end up with x minus 4 times x plus 21 equals 0, and we're off to the races there. Okay? All right. Now for applying this stuff to circles. Again, this second page is just more practice with this. So this is good mathematical practice for you also. Solve the equation, check the solutions if you need to. Again, all you got to do is plug the solutions in and see what happens here. All right. There's this factoring practice here. I'm going to draw up 2 example problems over here off to the side. And so I'm going to look at our secant rule real quick that we looked at it on our G notes. So I'm going to draw 2 secants right here, not drawn to scale, but I'm going to draw them anyway. So I'm going to have an X, a 3. I'm going to call this 2. I'm going to call that thing 7. Okay. Now, first thing, you know, this is just an example problem. It's not on here, but I just wanted to give you one off the top of my head here. All right. So we know, remember, we have to do outside times whole times outside times whole. So we know this whole thing is 9. Okay. And this whole thing is going to be x plus 3. Okay. You have to add the outside and the inside. Okay. So outside times whole times outside times whole. So on the left-hand side, we're going to have x times x plus 3. On the right-hand side, we're going to have 2 times 9, which is 18. Okay? So we end up with x squared plus 3x equals 18. Okay? Well, this is a quadratic because we have an x squared and an x. Okay? We can't solve for it. Okay? We can't, I mean, in a way, we can't get x equal to 0 to solve for it, or x by itself to solve for it. So we have to get the thing equal to 0. So we'll do x squared plus 3x minus 18 equals 0. Okay. Now what happens when we do this, again, we'll factor this out. So if I'm looking for 2 numbers that multiply to negative 18, add to 3. Okay, so two numbers that multiply to negative 18 and add to 3. And I'm going to skip the trouble here. I'm going to just put the numbers in. It's positive 6 and negative 3. Okay, if you were to do your chart of all the numbers that multiply to negative 18, positive 6 and negative 3 would be the two numbers that multiply to negative 18 and add to 3. Okay, so what happens is when we do this factoring out, we end up with x equals negative 6 or x equals positive 3. Okay, now in geometry, this is where we have to look at our solutions here. So negative 6 or positive 3 are our two solutions. Well, if I'm looking at this circle thing right here, this little piece right here has a length of x, right? Well, we can't have a negative length. So out of our two solutions, the negative 6 ain't going to work. Okay, but 3 does work. Okay, because again, we can't really have a negative length. Okay, so x equals 3 right there. Okay, so that's how we would solve one of those out. Okay, outside times whole times outside times whole. You got the equation. Okay, and you just solve it out from a quadratic, sort of like we did up there. Now let's talk about a secant tangent. And if you look at like the pre-AP problems on the 7G notes, this is sort of one that's going to like sort of look like that. I'm going to do this over here on the other side. So let's say we have a circle, and let's say we have a tangent that's x plus 4. Let's say we have a secant right there that has a 9 and a 16. Okay. Now, remember, outside times whole equals outside times whole. So, again, the whole thing down here is going to be 25 because that's what 9 plus 16 is. All right. So, on one side, we're going to have 9 times 25. All right. On the other side, well, the tangent, x plus 4, okay? The outside part is x plus 4. Now, the whole thing is outside, so the whole thing is also x plus 4. All right, so here's what happens. We end up with 9 times 25, which is 225. We have x plus 4 times x plus 4. And so when we FOIL that out, we end up with x squared plus 8x plus 16. Okay, now next we got to move the 225 over, so I'm going to have x squared plus 8x positive 16 minus 225 is going to be negative 209. All right, and so now we're going to have x squared plus 8x minus 209 equals 0. All right, now this will take a little bit of work, but so we're looking for all factors of 209, and you can even sort of research it on the internet if you want to and find out the numbers that multiply to negative 209. But what's going to happen is the two numbers that it's going to be are going to be positive 19 and negative 11. Okay, so we'll have x plus 19 times x minus 11 equals 0. Again, if you were to do your chart and find all the number pairs that multiply to negative 209, 19 and 11 would work in there. So we end up with x plus 19 and x minus 11 again. So that tells us that our solutions are x equals negative 19 or x equals positive 11. Okay. Now, obviously, x cannot equal negative 19 right here because this thing can't have a length of negative 15. Okay. It can only have a positive length. So 11 would be our answer on that. All right. So that's that for the 7H notes. Take some time and work on those. We have a couple of those on the next page as well. And best of luck, and you guys have a good day. Thank you.